part 3 here. Area of regular polygons. This is part 3. And in part 3, we're dealing with solving for the perimeter. What if you don't know the perimeter, right? What if you don't know a side? When you're missing a side. So that's what this is going to be all about. When you can't find the perimeter. Well, you're going to notice that on these problems, you're given the apothem. Okay, so basically, instead of solving for the apothem, we're going to use the apothem to solve for the missing side. And it's going to follow the same concept from the other one. You need to work with a right triangle of some kind. Okay, now we're still going to do the same thing, in which we're going to do 360 divided by the number of sides. So in this case, it's going to be 360 divided by 3, so that's 120. But 120 is this big angle here. I want just that piece. Your apothem cuts it in half. So 120 divided by 2, that's 60. So when I'm working with my right triangle here, sure, I know that this is 4. But this 60 is the angle that goes right in there. Okay, so that is 60 degrees. Now, ultimately, I am looking for my side, so I'm going to call this x. Keep in mind that my angle happens to be 30, because the angles in a triangle add up to 180, and that's already 90. Okay, so once again, I could do a quick law of sines, or I could do a quick SOHCAHTOA, or 30, 60, 90. Okay, and again, I'm going to be sticking to law of sines because it's more universal. Okay, but if you guys want to do some SOHCAHTOA, feel free. Doesn't really matter. For those of you guys that, you feel very comfortable with law of sines, I would challenge you guys to do it with SOHCAHTOA, okay? So that you could get your practice. I think law of sines, on one end, it's a little too easy. SOHCAHTOA is also pretty straightforward, but you want to have an understanding of how to do both, okay? So please, if you already know how to do law of sines, try it out using SOHCAHTOA, okay? And then just check your answers. All right, so again, I'm going to stick with law of sines for the mass. And we have here 4 goes with the 30, so 4 sine of 30 is to x to the 60, x sine of 60. So again, quick cross multiplication, it becomes 4 times the sine of 60 divided by the sine of 30. So I found out that my side, or not necessarily my side, but this side of the triangle, which is only this piece right here, is basically 6.9. Now this is x, right? And my apothem cut it right down the middle. We would expect this part to also be x. So when you want to find your side, whatever you get, you need to multiply it by 2 to find out what your side is. So your side is going to be equal to whatever you get times 2. Okay? So each side in my triangle is 13.85, and I'm just going to say it's 13.9. I'm going to round up to the nearest tenth. So this is 13.9. Okay. So now that I know that, I could easily find my perimeter, because there's 3 sides. So my perimeter is 41.7, whereas my apothem, which I already knew it to begin with, was 4. And again, if you know those 2 things, you will be able to solve for the area. All right, next part right here. All right, I'm gonna keep this one short and simple, guys, since we already, did the heavy lifting on part two. Um, and now we move on to the hexagon. And again, once again, we really only care about this right triangle right here. Um, and to find out what this little angle right here is, same thing. We're gonna get 360, and we're gonna divide by the number of sides. In this case, 6. I get 60. But I have to divide that by 2 because I only care about that little piece. So 60 divided by 2, that is 30. Okay, so when I'm working with my right triangle here, when I'm working with my right triangle, let me make sure we're all looking at the same thing. Yeah, when we're looking at my right triangle, uh, I know that my apothem was 10. Okay, I am looking for this little piece right here. I know that the angle that goes up here, make sure you put the angle in the correct location. Put it in the wrong place, you're going to end up with the wrong relationship. And so the x goes with the 30. And the 10 that we know is across the 60. So once again, we do a quick cross multiplication. So we have 10 times the sine of 30 divided by the sine of 60. So we just found out that this little piece right here, which represents half of my side length, is 5.77. And my actual side length, when I multiply it by 2, is 11.5. So every single side here is 11.5. Now that I know that, I can easily find my perimeter. I just get 11.5 and I'm going to multiply by the number of sides. So my perimeter here is 69, and my apothem, which I already knew to begin with, was 10. And again, you know those two things, you will be, one step closer in solving for the area. All right, we have our octagon, and again, it follows the same concept. You have to make your own little triangle when it's not there. Okay, so we're gonna do 360 divided by 8. If you don't know what shape it is, all you have to do is just count the sides, right? If there's no tick marks, you write them in yourself. 1, 2, 3, 4, 5, 6, 7, 8. That's why I'm dividing by 8, because there's 8 sides. And 360 divided by 8 is 72. But again, we must get whatever we get there and divide it by 2. And so we draw our triangle. So we have our right triangle, where originally this was 6. I found out that the angle right in there was 36 degrees. And if I calculate this angle right here, again 180 minus the 36 minus the 90. And yes, guys, you could technically just do 90 minus 36 on these because they're right triangles. So the angle here is 54. We're looking for x, where x represents just half of your side. And again, x is to the sine of 36, just like 6 is to the sine of 54. Again, this becomes very repetitive after a while, and hopefully you have pretty much understood the pattern. So divided by the sine of 54. So I just found out that my half side is 4.359 something, right? And each side is actually equal to 8.7. And if I wanted to find my perimeter, I just get my side length and I multiply it by the number of sides. So the perimeter is 69.6 and my apethym, which I already knew, was 6. Okay, once you know those two things, you just plug them in and that's pretty much it. All right, last one I want to talk about is a pentagon, but again, it is the same thing. Same thing. So I would like for you guys to go ahead and calculate the angle. Okay, go ahead and put pause really quick. Put pause and calculate what the angle will be. All right, so for the angle, let's make sure we got it right? So we did 360. All right. I just noticed, guys, I made a little mistake here because 360. This is what happens when you think you know it and you really don't, right? So right here, guys, on this one, guys, my bad. The angle here should have been a 45. The angle here should have been a 22.5. So please be very careful when you're working this out. There is obviously room for error. But I mean, I had it here. There was no reason for me to come up with different numbers. So obviously that's going to change my answer here, but not in a very, the setup is still the same. So when you make mistakes like those, it's so easy to fix them. Okay, so this should have been a 22.5, and this should have actually been a 67.5. Okay, again, I apologize for that mistake. I'm just glad I caught it right now. So this should have been basically 2.5, which would have made our sides 5. Okay, so obviously my perimeter would now have been 40. Again, a silly mistake on my part. Okay, but again, I'm glad I saw it right now. On my pentagon, and this is where I realized I messed up after seeing those numbers. So 360 divided by 5, right? That is 72, okay? And then 72 divided by 2, that's 36, right? Oh, this one should be a 45. Okay, 45 divided by 2. Okay. So again, it's the same thing, okay? We have our triangle. This is 10. This right here is 36. This right here ends up being 54. And this right there is 67.5. Okay. And so if I want to solve for half of my side length, it's just a matter of doing the quick relationship. X is to the sine of 36, just like 10 is to the sine of 54. So we do a quick cross multiplication where it's now 10 times the sine of 36, right, divided by the sine of 54. So each half length is 7.265 and so forth, right? So I have to multiply that by 2, and so every single side is actually about 14.5. And so I want to find my perimeter. I'm just going to multiply that by 5 because there's 5 sides. So my perimeter is 72.5. My apethym was 10. Once I know those two things, I could easily find the area. Okay. So again, guys, please forgive me for that mistake on the octagon. Please go back and make those little corrections if you were writing with me. But again, please realize how relatively simple this is once you get the hang of it. Okay. Check them out, guys. And yeah, that's it for this one.